Okay, we're at Contemporary Math, Section 3C, which is on page 155. Start off by talking about significant digits. I'm just going to jump into some examples, and I know that you guys have probably heard about significant digits. Usually when you're talking, when you're in science, they use a lot of significant digits in science. So the first example, a time of 11.90 seconds has 4 significant digits. And this, because the 0 at the end, implies that we are rounding to the nearest 1/100th of a second. Zeros after at the end are significant, leading zeros are not. A length of 0.000067 meter. There are 2 significant digits, and this implies rounding to the nearest, what is that, 10th, 100,000, 10,000, 100,000, millionth of a meter, because that's where it ends. A weight of 0.0030 grams. Remember, these leading zeros not significant, this one is. So there are 2 significant digits, and this implies rounding to the nearest 10,000th of a gram. A population of 240,000, there are 2 significant digits, and this implies rounding to the nearest 10,000 people. A population of 2.40 times 10 to the 5th has 3 significant digits, and this one implies rounding to the nearest 1,000th people. 240, 3 significant digits. All confused here. Here we go. So let's talk about types of errors usually used in measurement. Random errors are random and unpredictable events in the measuring process. Systematic errors are problems in the measurement system. So the book has a really good example of how to define really what the difference between random errors and systematic errors are. So let's say you work in a doctor's office and your job is to weigh babies all day. Well, you can imagine how hard it is to get an accurate reading on the weight of a baby who's moving around all the time. So you put them on the scale and they wiggle and wiggle, and let's say you have a baby that comes up at 14.5 pounds. Well, that could be anywhere from 14.5 to 15 pounds just because of their wiggling around on that scale. That's an example of a random error. Let's say at the end of the day, you discover that your scale is off by 1.2 pounds. That is a systematic error because it's a problem in the measurement system. And it would affect all the weights that you recorded that day by 1.2 pounds. Size of errors is something else we talk about. So the absolute error is just like any other absolute value. You take the measured value minus the true value, that gives you the absolute error. And the relative errors, which are expressed as a percentage, is the measured value minus the true value divided by the true value. So the difference divided by the true value times 100 will give you the relative error. So as an example, let's say you weigh 125 pounds, but your scale reads 130. And I know that the absolute error is 5 pounds, but I want to know what percentage 5 pounds is of what you really weigh. So the difference, which is 5, divided by 125 times 100 is 4%. So we can say that this scale that you're on increases your weight by 4%. And then the last topic we're going to cover this week is accuracy versus precision. All right, so accuracy describes how closely a measurement approximates a true value. There's a small relative error. And precision describes the amount of detail in a measurement. So let's suppose your true weight is 102.4 pounds. And the scale at the doctor's office says you weigh 102.25 pounds. So the scale at the gym says you weigh 102.7. Well, let's look at these two scales. The scale at the gym gives your weight to the nearest tenth of a pound, while the doctor's scale gives your weight to the nearest quarter of a pound. So the gym scale is more precise in its measurement because it's to the nearest tenth of a pound rather than the nearest quarter. But the doctor's is more accurate because it's actually closer to your real weight. 102.25 is closer to 102.4 than this one is. So we say that the gym scale is more precise, but the doctor's scale is more accurate. And then one final note on combining measured numbers. Always round your answers to the same precision as the least precise in the problem. So if you're comparing two measures, combining two measures, and one is to the nearest hundredth and one is to the nearest tenth, your answer should be to the nearest tenth. Round your answer to the same significant digits as the measurement with the least number of significant digits. So if you're combining two measures and one has 3 significant digits and the other one only has 2, then your answer should be rounded to 2 significant digits. Also, a quick note, only do rounding after you do all of the calculations. Don't round in the interim steps. Okay, that's it for 3C, and your assignment is the quick quiz on page 163. See you next week.